There we go. I don't even know if that's the correct reading. It's in your syllabus and your work, but we're going to talk about precision measuring, torquing, and safety wire today. That'll take us about 3 hours or so. So one of the first things I want to talk about, did I make that go? I did make it go. Yay. One of the first things I want to talk about is, not that, let's get rid of that, bring this back, beginning. There we go. All right, is precision measuring. So precision measuring, this is a micrometer. Pay no attention to the scale on there because that particular scale, this is off of a metric one, which we're not going to get into metric. But we're going to be doing precision measuring with a micrometer. And so you're going to get very comfortable, I hope, using a micrometer. It's just one of those things that once you unlock it, you do it over and over, it becomes very simple to do. At first, it may be rather difficult for some of you. Don't give up. Just keep persevering and you'll figure it out. Hopefully you'll figure it out right now. So let me pull up my notes so I can make sure I'm following correctly. All right, precision measuring. We have all kinds of different precision measuring tools. This is the one we're going to cover right now. Let me see, I want that right there. Okay. So before we get into exactly how to read it, let's cover a basic decimal workage here. So when we have a decimals, like if we had 1.12345, there's my decimal place right here. This number right here represents the ones place. Ones. And if I went the other way, it'd be the tens place. But when we go this way, this number right here is going to represent the tenths. That's 1/10 position. This one right here would be the hundredths. Hundredths, or 1/100th of an inch. The number 3 would be thousandths. So it's 1/1000th of an inch. The 4 right there is 10 thousandths. Wait, now 1/10,000ths of an inch. And that's as far as we really need to go for micrometer reading, because that's as far as we're going to go with micrometer. So we don't have to worry about the 5 right there. So tenths, hundredths, thousandths, 10 thousandths. And there's different ways to say things, and we'll get into that, how we do it, and proper way and how it's done. So anyway, so we have this right here. Now a micrometer such as this one is going to read down to the 10 thousandths of an inch. And I will show you how to do that. But first, let's get kind of wrap our head around what these sizes are. So let's do size references. Size reference. Size reference. Well, piece of paper. Told you the other day, anybody remember? About how thick is a piece of paper? 3,000. Yeah, about 3,000ths of it. About, depends on the weight of the paper, but the average would be about 3,000ths of an inch. A hair. I guess it depends on the color, but we'll just say an average. About 4,000ths. Aluminum foil. I hear 2? 2,000ths? It is. The heavy duty is about 1,000. 1,000ths of an inch. And when you're working on aircraft engines, you're spending most of your time down here in the 10,000ths. Well, you got to read the whole thing, but we care about 10,000ths of an inch. So that's kind of where I live my world. So, all right, so how to read a micrometer. How to read a micrometer. Let's go to the nomenclature pieces. And so you'll have to write these down. I'm not going to write all these down. But we have a micrometer. And we can start down here where it says heat insulated handle. This one doesn't have it. That one does have one. And the reason why you want to insulate it from heat is because temperature changes can actually affect the accuracy of the micrometer. Whenever we measure something on an aircraft for return to service, it must be calibrated. So everything used, I'll write that down. Everything used to measure return to service, quality, I guess, must be calibrated. So when I say everything, if the book says this must measure that, then whatever you're going to measure that with has to be calibrated. If it said it must be exactly 12 inches, you'll use a tape measure, I suppose. Well, a tape measure's got to be calibrated. It depends on what increments it's in, 12 inches plus or minus 1. You got to have a calibrated tape measure. If you're going to measure something return to service micrometer, this has to be calibrated. If you're going to measure voltage has to be calibrated. So every single thing that has a number and you use it on the airplane has to be calibrated. If you say you're going to torque it to X number of inch-pounds, torque wrench has to be calibrated. So everything. So the way these are calibrated and how often they get calibrated depends upon where you work. In general, they're done at least once a year. And it will depend on the repair station. My repair station, we had a calibration lab. He had a gigantic trailer. He showed up once a year and everything went into the trailer. And he would calibrate all the micrometers, and he would also calibrate these. They're standards. And standards come in all different sizes. I just happen to have a 1 inch, which is exactly 1 inch, and exactly 2 inch, and exactly 3 inch. This particular micrometer is a 0 to 1 inch. So to calibrate it, funny as it may seem, you can do one of two things. Close it, and everything should read 0, perfectly 0. Then it's calibrated. Or open it all the way up to 1 inch, put in the 1 inch standard, and it should measure exactly 1 inch. There we go. Just stick that in there. Close it down. Now listen. Almost all micrometers have some sort of clutch mechanism. Just like on your car, when you go to tighten the gas cap, it starts clicking when you get it tight enough. It's so you don't over tighten it. So if I wanted to, I could start wrenching on this back here, and I could tighten it even more. All I'm doing is spreading it open, damaging it. And what students tend to do, I don't know why, I wish I could break everybody this habit, but there'll be at least half of you will do this. You'll put a micrometer on something, tighten it real tight, and then go, oh look, it clicks. Now if you didn't understand why that's bad, I need to say it again. You over tighten it, and then what is this going to do? Yeah, it's going to click. Why is it clicking? Because you tighten the living crap out of it already. Of course, it's like, oh, you're plenty tight. So you tighten it with this back here, and then it just gets only tight enough. Follow? Just locked up on it. There we go. Okay, so I'll say it again. You only tighten it until this clicks. If you over tighten it, of course this is going to click, because you've already gone past the minimum tightness. You've already spread this open and you got a bad reading. Everybody follow that? Everybody follow that. If you don't get that, now's the time in the course where you got to start saying, oh, well, I don't get that. Otherwise, I'll have to make an example out of you in the lab. They're like, all right, here's a guy who didn't understand lecture. Everybody, so don't be that person. You got to be brave. And you got to say, I don't get that. So, yes. He's brave. I like this guy. All right. See, he's an honest man. He's going to do very well in this industry. All right. Maybe because I'm saying, so when it clicks, it won't get any tighter. Right? But if I want to, I can force it tighter. See, if I force it tighter, this still clicks, but now it's way too tight. Right? It's not measuring correctly. So you only tighten it until whatever mechanism stops it. That keeps you from over tightening it. If you don't use this, you'll accidentally over tighten. And then you get a bad measure.
I'd rather use this one, right?
Yeah. Some of them, it's out here. Some of it's here. You gotta find it. Like this one. Some of them, and some of them don't work. This one's out here. It's the opposite. So it won't let me over tighten it. All right, we have to calibrate. How often do we calibrate? At least once a year.
So do we have to send them in to have be calibrated, or can you do it in the field?
You can hire a guy to come out and do it, or you can send them out to get done. You can just have these calibrated. So if you have a bunch of these, you can send these out to get calibrated. They come back and these are calibrated, then you can use that to calibrate these. You can do it yourself. Follow? So as long as you have something that's calibrated, then you can reference that calibrated item, then you are good to go. So, okay, so everything's got to be calibrated. We'll say once a year. All right, so we've got our insulated handle. That fits real nice in a vise. You can put it in a vise and just squeeze the crap out of it, right? Because it's a precision tool and that wouldn't bother it. Okay, do not put this in the vise. Do not put it in the vise. Even if you put rags on it, yeah, if you want to do it with your own, that's fine. But when I catch people doing it, I'm like, don't put that in the vise. Like, but I barely squeezed it. I know, and you didn't damage it, but it looks terrible. Don't do it. So don't put the heat insulated handle in the vise. All right, you have your anvil and your spindle over here, and it has carbide tipped, the carbide tips on it. And the point behind saying that is that that carbide is very, very strong, but brittle. So it's brittle. If you drop it, you can crack it, but it is very hard is the word I wanted. It's very, very hard, and so it's usually harder than the thing that you're measuring. So if you're measuring a highly polished crankshaft and you're dragging this across there, what's going to get scratched? Crankshaft. The good news is crankshafts are really cheap in aviation. This particular one is probably only in the neighborhood of $6,000 if you could find one. And that's the smallest one they make. They go up from there. All right. Let me pull out this over here. So when we're measuring something, you're just going to have to get, man, I don't think I like these. They come apart on me. That's why I brought this in, so I can put stuff up there, which is probably not on camera, but whatever. So when we're measuring something, we're going to put it on here, and we're going to over-tighten it, and then use this little thing right here to make sure it's tight enough, right? No, okay, we're going to use this right here. And you can click it all day long, but don't be that person at the gas station who does that for 20 minutes. All right, so put it on. There we go. And we want to make sure that we didn't have it, I'll try to exaggerate, like this, because if I had it very crooked, still clicks, right? But do you think I got a good measurement? Okay, so no, I did not. So even there, okay, that looks good, but it's not. So make sure you're on there. Nice. Lock it. See if there's a locking device. Lock it, slide it off. This is highly polished. It should slide right off without any problem. You don't have to go back on and see how it feels and back and forth. All you're doing is scratching things up and taking time. So put it on. Make sure, I kind of go back and forth like this. Make sure I'm on there right. Lock it. Slide it, read it. All right, so you got the ratchet, got the thimble, vernier scale. Can't tell if that's it. Carbide tip measuring force. Let's see, I think that's everything we have to cover. We're going to spend a lot of time talking about the sleeve and the thimble. So the thimble is the moving part. The sleeve is the part that stays. Everybody's with me so far? All right, that's a good thing for me. Yes?
How do you know you're on the widest part or the largest diameter of the crankshaft? Or you just know?
That's a very good question. I don't know. Crankshafts, I just know.
Gotcha.
If it's a big circle like a cylinder, it's much harder. One way that you can tell, if you're just not sure, you can, in fact, I'll make sure I'm not on there, which is actually harder to do than I think. There, okay. I know for a fact I'm not on there. And then you can try and put it back on. I guess that was harder than you think to actually not do it correctly. I don't know, honestly, if you look at the tips on here, you can just see that it looks right. I know it's a terrible thing to say, but you can try and go back on if you want. If it won't go back on, then you didn't get it in the right spot. But it's, when you're doing it and you're looking at it, it's to me, it's just so obvious. A big circle, this is completely different. Trying to find when you're in the exact apex, that's a whole nother story. That is very difficult. All right. Put that down before it drops. All right, so let's learn how to read this thing here. I want that. Okay. First thing, calculator is your friend. I will never, and I mean this, promise you, I will never make fun or even think bad of somebody who takes out a calculator to do the most simplest of mathematical equations. I don't care how simple it is, 1 plus 3. When I'm standing over you, I understand that you're going to be very nervous, your brain isn't going to want to work the way it's supposed to. It's more important to be right than to look cool under some circumstances. Sometimes it's more important to look cool, but in this case it's not. So use your calculator. Don't be afraid. I do it. I have no problems with it. Just use your calculator if you have to do some simple math. It's totally fine. I have the time. I don't mind, so don't worry about it. All right, so micrometers. Micrometers have 40 threads per inch, TPI. That's threads per inch. So every micrometer is pretty much will only measure 1 inch worth of something. This particular one is a 1 to 2, so it will measure things that are as small as 1 inch and as big as 2 inches. And this one is a 0 to 1, so it measures all the way to 0 up to 1 inch. And so for that 1 inch, the thimble's going to go around how many times? 40 threads per inch, which is, if I counted the threads, it means it'll go around 40 times for that 1 inch. I tell you that to tell you that for every 1/10 of an inch, for every 1/10 of an inch, it will go around 4 times. That's an important thing to understand. So for 1/10 of an inch, that's 0.1, has to go around 4 times. So if we divide that by 4, so for every time it goes around, for every rotation, you measure 0.025. So if it goes around once, we measure how much? It opened up how much? We'll just say that. If I have it all the way closed, turn it around one time, it opened up how much? 0.025. Right, and if you ever get confused, okay, so that is tens, hundreds, thousands, we can say 25 thousandths. Yeah, or 0.0, just say 0.025, nobody gets confused. All right, every rotation is 0.025, so it goes around once, it opens up how much? 0.025. Goes around again, it opens up how much? 0.005. Opens up one more rotation, it's 0.075. Opens up one more rotation, opens up to 0.1. All right, follow me? Okay. Yeah.
So when measuring, the measurement isn't shown on the actual micrometer?
Yes, it is. That was
You're supposed to count every rotation.
You do not count the rotations, but it's helpful to start understanding what we're going to talk about here. So I got it facing the right way for you guys. Everybody can see that okay? Maybe if I turn it well, last time I did this, I had to hold it up like this for an hour. For that. All right. This right here is the thimble. This is the part that rotates. This right here is a sleeve. This part does not rotate. So we got our thimble, the part that goes round and round and round. Yeah? Everybody follow me? Okay. So what we're going to do is we're going to read it along this line right here. That's the 0 line. So my micrometer, we'll say it's a 0 to 1, is all the way closed. It should look just like that. It's on the 0. It's on the 0. That is all the way closed. So if it goes around one time, it opens up how much? 0.025. So if we looked at the thimble, I'm going to regret taking this off, I know it. If we look at the thimble that goes around, it goes up to 20, 21, 22, 23, 24, 25, back to 0. So got 25 lines. So each one of these lines is how much? Each line on here is 0.001, 1/1000th of an inch. 0.001, and that's the place to start right there. So if everyone is 0.001, and I move it just a little tiny bit, how much does that measure?
0.002.
0.001. 0.001. All right, you're reading the horizontal line, right, where it matches to this. 0.001. We got that? So if I measured a piece of paper, it would be about right there, which is 0.003. Okay. Now, of course, there's not threads. I have to kind of simulate here and moving this way as I go. Every micrometer has what I call a personality. And until you're really, really good at micrometers, stick with the same one. So when you're doing a project across the street, you get a micrometer set, just use that one. What I mean about micrometer personality is sometimes when you look at it, like that might be 0.003, or maybe that's 0.003. You can't even see the 0 going this way, right? Or maybe you see a little bit more of it. And so it's going to get confusing when you get into it later. So just work with you on that. All right. So we got, everybody see that? 0.003. All right, turn it around some more. How much we got right there? 0.010. All right, we keep going around. We got 0.017. We keep going around. What do we got there? 0.024. Now notice we can start to see that next line going this way. But we can barely see it, and so that's 0.024. And I move it just a little bit more, and we have 0.025. How many times do we go around? One time. Yep.
So you're saying that some micrometers will show you more or less of the 0 or something?
Yeah,
like that, or whatever?
like some of them may, like now that I'm out here, some of you may not quite see that line right there,
Right.
but you see all that space?
Right.
Okay, that's not 0 because you got a big space. So you'd say, oh, that's 2.5. And then some of them will be like this, and you'd be like, oh yeah, I totally see the line and it's on 0. It's not 50, it's 25. You just have to understand that sometimes they're in and out a little bit.
I understand. I was going to ask if during calibration, if that has anything to do with
It
calibration.
doesn't seem to. It's the way they're printed on the. It's the way it's printed.
So
The horizontal lines are always true.
Just hang on to that. As my new saying, let's park that right now.
All right.
Put that in the parking lot and come back around. And then you'll see what I'm talking about. I probably mentioned it just a little too early. All right. So then we come around. We've got there. Okay. So now here's where I strongly suggest, unless you're really mathematically minded and you see numbers in your brain, just get a piece of paper and write things down. Don't make it hard. Because when I'm watching you, I can see what you're doing. So what do we have right here?
0.030.
Okay, so now let's look at these lines here. Slide this way back. So we have the 0 that goes around one time. It's going to come to right here, which is 0.25. And here's the second time around is 0.50. That is 0.75, and that is 0.1. Okay, so where I had it right here. So the way I would do it is say, first of all, I have 0.025. Then I have 0.005 and add them up, 0.030. Yes, 0.030. All right, everybody's with me so far? This is pretty easy, isn't it? Everybody's saying it's easy? Okay, I didn't lose anybody yet? Serena, why are you looking at me like that?
No, just, we're good.
Just, switch seat. Okay, so we keep on going. Let's try and work something out over here. Let's just skip ahead a little bit, see how we're doing here. All right, so what do we have there? Okay, so now when we look here, we have 0.1, right? How many lines do we have going this way? Sorry, this
One.
which is, so let me write that up. We have 0.1 for this one right here, 0.1. Got it? Okay, then how many, then we have one more line, so it's gone around once past the 0.1, so that is 0.25. And how many thousandths do we have on the thimble? 12. 0.012. Where do you follow that? Add them up. 3.137. Everybody got 137? Okay. Well, let's see here.
Hey Kevin,
Yeah.
how'd you get the 12 again?
Right here.
The thousandths? Oh, okay, yeah, that's
15?
right, yep,
Okay.
on the thimble.
Yeah, and that can sometimes be a little hard because we had 0.025, a 3-digit number, then 0.012, also a 3-digit number. You just have to remember when this goes all the way around, this goes up to 0.025 on this one. So we're taking pieces of that. All right, so let's go over here and let's do. Like that. All right, so what do we have? Well, let me do difference. You can see numbers better. Okay, so we look at something like that. We've got. So give it to me in pieces. So what do we got?
0.075.
Well, we're going to start. We got the 0.1. I can't see it now. It's 0.1, right?
0.1.
Okay. How many horizontal lines then do we have after that?
0.075.
0.75. Okay. Then all we have is the thimble, which is 0.19. So 4, carry the 1, 9.194. Yeah? Okay, 0.194. This is pretty easy, isn't it? All right, let's make it a little more challenging. Okay, what do we got there?
0.050.
I got point. What do we got? Point 1, yeah?
0.024.
Point 1. Okay, now how many of these we have?
It's not quite to 0.050. Is that what it is?
It's 0.24.
Well, is it 20? Well, do I have 25? Do I hear 25? 0.025.
0.025.
Do I have 0.50?
No.
I do not. You can see it though, right?
Right.
It's not to 0 yet.
But in a real one, in just a second, it's going to go 2.5 and look like that. Now it looks right. So you can't count that one because even though it's showing, there's no space. So it indicates it's coming up on 25. So that's 0.024, I'm sorry, 0.025 plus 0.024, so 1.149, right? Okay, got to watch out for that one. That's the trickiest one right there. Let's see, you guys are learning this too fast. Now let's just move on. All right, let's try. Let's try that. Okay. I don't remember what I set it at. I just threw it there. So what do we got? 0.1.
5 and change, but
0.1. Then what?
oh.
0.055.
No, what? We're not jumping at it. It's just, what does this say?
0.005.
Okay, 0.005. and he said this, he used my words, and some change. Well, what does that change? We're aircraft mechanics. We don't ignore it and we don't round. Because you can't round something, go, well, it's actually, you remember the story of the brake disc? Well, that guy would have been great if he would have just rounded up, right? So you can't round up. It's exact. So we have to be as exact as we can. Now, not every micrometer has this, but there is a vernier scale printed on the side of a lot of micrometers. And it goes 0 through 0 over here. So what we're looking at, because they put numbers here, these numbers must mean something. If they didn't, they would just be lines. That's how I remember it. Now we're going to ignore these numbers and look at these numbers. And all we're going to do is look at which of these lines line up with those lines. So nothing lines up with that one, or 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 that one. That one lines up pretty dang close. That one's off. So that one's off, that one's off, that one lines up. You see that? Nothing else, none of these lines line up with any of these right here except for that particular one right there. And that particular one happens to be a 4. So that makes that 0.0004. Now, if it didn't have a vernier scale, I say you're still held responsible for that. A lot of you said it was 5. Who says it's 5?
I did.
I would agree with that. If this did not have a veneer and you said it's 5, like, yeah, sure, that's what you said. I agree. So you just have to make a guesstimate. Like, you know, that would maybe be 1 or 2. That would be about 3, right? Halfway is 5. 1 more is 6. 1 more is 7. So you have to figure out that veneer scale right there, that 10,000th of an inch. All right, so given that, go back very far. Let's see. There, big as I can make it. What do you got?
Turn it over.
You should know better. It'll fall apart if I do it that way.
0.241.
All right, what do we got? So we've got 0.2, 0.025, 0.015, because it's not to the 6 yet, and then that's going to be about 6 or 7. Let's see. Whoever made this did a dang good job. It looks more like a 5 when I'm holding it right here. So this way I'd say it's a 5. But this way I'd say it's about a 6 or 7. Either which way. So what do we get?
0.2405.
2405. Everybody agree with that? All right. What I was hoping to do with all this camera setup I did, which will not show up on a video, but I wanted to give you a little more practice, and I can't get it to display over on that side, but let's just see if this works for just a second. We'll see what we can do. I was hoping the lighting would be a little better on this than that. That may not work. Also, up is down, down is up. Well, I can't say I didn't try.
Want a flashlight?
I do have one. There's a light on here, but see what happens when I turn the light on. It just washes it all out.
Could turn off overhead lights and we'll
Try
just
that.
plug it back in.
Click that one. Would you do that?
Well, that's good.
Open the window.
Okay. Can you read that one?
Yes.
What do we got? Point 3, 0.50, and then 10, 11, 12. That'll be 13, so it's 12.012. And then how much of veneer you want to give it?
7.
7? Let's see if we can. Maybe if I hold this further away and then zoom in this way. That still ain't worth a dang, is it? All right, I tried. Also, right is left, left is right. Which one lines up? 7. All right, so did you guys get it?
0.3627.
All right, 0.3627. Let's see if we can try one more. I'm trying, I really am. There we go. Everybody get it? Yeah.
So the bottom line right above the notches for that is where the it lines up.
This is the 0.
Yeah, yeah, this is 0.
So I've got 0.6, 0.050, 0.001, and then about half a thou. So half a thousand's 0.0005. So 0.6515. 0.6. Write that down. Be over there. 0.6, 0.050, 0.001, 0.0005. So 0.6515. Yes.
What makes that one the 10,000th one? Oh, my bad. You rewrote that 0005. Okay, I got the second answer.
All right, let's try this one. This is a 4 to 5 inch. That's angled a little bit different, but maybe it's a good thing. What do you got? Everybody got something?
4.2685.
Ooh, he got it. 4 point. Why is it 4 point? It's a 4 to 5 inch micrometer. So 4 point. We definitely got a 2 on there. 0.2. We have how many lines going down after that? 2. So that's 0.050. These 2 lines right here. 1, 2. And then how many thousandths do we have? 15, 16, 17, 18. So 0.018. 0.018. And then we can actually see this one lines up on the bore. So 0.0004. And if you're not used to manually doing decimals, always make sure that the decimal lines up and you have all the zeros and all the columns. So that's 4, 8, 6, 2, 4.2684. Yes?
Can you explain how you got the 4?
The 4? So it's 4 10,000ths. It's more than 1,000, right? So each one of these lines right here is 1,000, right? 0.001. So every one of those lines is 0.001. So we could divide this up by 10, and each one of those would be 0.0001. You know, if it was right there, 1, 0.001, 0.002. Follow me?
I mean
Yeah.
the 4 in the ones place. The 4.2.
Oh, right here?
Yeah, how do you get that 4?
It's a 4 to 5 inch micrometer. So it's measuring, as the smallest it can measure is 4 inches, the biggest it can measure is 5. And so it's in the middle, so it's 4 point. If it was this one, this is a 2 to 3, it would have been 2 point. This is a 0 to 1, so it's always 0 unless it's on its absolute biggest setting. And I have some more over there, but I think you get the idea. All right, it is your break time.